To a pure mathematics video. Today I will be recording on limits and continuity. So let's get started. So let's suppose we just graphed a function and we'll call it f of x. So we just this graph right here is of f of x. Now let's say we wanted to find the limit of this function. And we'll say the limit as it tends to x equals 1. So first you want to do is find x equals 1. So x equals 1 is right here. So you probably don't understand the terminology if this is your first time hearing about limits. So we'll break it down. We're trying to find the limit of f of x as x tends to or x approaches 1. So first what you'd like to know is that if x is approaching 1, it can approach from two directions. It can either approach from the left, approaching from the left to get to 1. Oh, sorry, my bad. This looks kind of weird. I want a better looking stroke. So it can either approach from the left, or they can approach from the right. Now, what this means is that when x tends to 1, it approaches 1. And so what we need to know is that the x value here kind of doesn't make a difference. The x value is kind of like our input. So we input an x value as x tends to 1, so the input is 1. And what we're trying to find is the output. What is the limit as x tends to 1? So when x goes up to 1, or gets close to 1, what value of y will we get? So using the graph, we'll look up and we'll say, well, if we connect the dots, we'll get 1. Now, here's the thing. That is very true. But there are two different ways you can look at this. So x can come from either left or right, right? So we'll just mark them here. We'll say right-hand side and left-hand side. So as x is going to 1 from the left-hand side, you realize that it'll have to pass like 0 0.5, 0 0.9, up to 1, right? And for the right-hand side, it'll pass 1.5 and like 1.1 and as close as it gets to 1 without actually touching 1. Well, it could touch 1, but without actually getting to 1 is as close as we'll get because it's approaching 1. And this looks kind of jumbled right now, so I'll just kind of erase it a bit because it looks kind of disgusting. But you get the point. We can approach from the left-hand side or the right-hand side. And what the limit essentially is it's a point where the graph may not hit, but it can approach it to a certain degree. So let's look at the things that allow a limit to exist. So for a limit to exist, let's write as the existence of a limit. Yeah, so for a limit to exist, what we need to know is that the left-hand limit, I'll write it as LHM, it must exist at x is equal to a. Right, so the left-hand limit exists here because, my iCloud, I'm sorry. So as x approaches 1, where x is the a value, the limit is 1 because that's the output value we get back for the y. Right? And for the right-hand limit must also exist at x equals a as well. Because you see, when you come from the right-hand side, you have 1.5. Coming down, it does exist. It does exist because it comes down all the way as close as it can to 1. So both have a limit, but the thing that actually allows this limit to be true or to exist in truth, right, to actually exist, is that the left-hand limit and the right-hand limit at x equals a is equal. So the left-hand limit is 1 and the right-hand limit is 1. So what we want to know is that at x is equal to 1, the left-hand limit and the right-hand limit must both be equal to that value. And that is true in this case, at least. As x tends to 1 from the left-hand side and right tends to 1, we get the same y value. So that's good. So good. You now know, like, what causes a limit to exist. So let's get a little further now. So these are things that will be tested for CXC. I am not sure about anything else, but these are the limit laws. I'm resizing it so that we can kind of get a better look. Now, I have never actually seen them test a question where they ask you directly about the limit laws. I think it's just something that's very good to know. So if you would like, I'd recommend that you take a moment and pause this video. And yeah, if you can do that, then good. So once you pause this video and kind of looked at these a lot, if you've done logarithms already, these become kind of intuitive. And if you haven't done logarithms, then I'd recommend that you check my video that I posted last week, I think, or my last video. So the last video I posted on this channel, and it's in the Pure Mathematics playlist. If you check that out, that should work as well. So yeah, everything's working well. Good. You have this down. Nice. Now let's look at evaluating limits. I'll use white now. Evaluating. So let's say we have the limit as x tends to 2 of 3x squared plus 4x minus 2. So this is the way that it's denoted. Limit, this is the sign for limit, as x tends to, so we use this arrow to say as x tends to, or as x approaches the value 2 of f of x, and this is f of x in this situation. This f of x will be equal to 3x squared plus 4x minus 2. So how do we evaluate this limit? So to evaluate this limit is very simple actually. We can use direct substitution. So we take the 2 and we just plug it into here. Please pause the video and just mentally work it out so you kind of have it in your head because it's better to be engaged. So we'll just substitute wherever we see x, we'll substitute it for 2. So 3 times 2 squared plus 4 times 2 minus 2. This will be equal to, so 2 squared is 4, 3 times 4 is 12, 12 plus 4 times 2 is 8, so that's 20 minus 2 is equal to 18. Great. Now that you know how to kind of evaluate a limit, I'll only go through one limit question per, I guess you could say per like time. Not time, but I'll go through one limit question per method of evaluation. Yes, that's it. So there's another method now. This other method is called the factorizing method. So let's say you have limit as x tends to, let's see, negative 2 for x squared plus 5x plus 6 over x plus 2. Now, if we plugged in x equals minus 2, right, we'd have minus 2 squared, which is 4, plus, so I'll do it. So minus 2 squared plus 5 times minus 2 plus 6. So you realize that this is 4 minus 10 plus 6. And if you evaluate just the numerator alone, you'd realize that the numerator is equal to 0. And the denominator is equal to minus 2 plus 2, which is equal to 0 over 0. Now, this is not allowed. You can't do this for a limit. This represents something else, and it's just not determinable. So, what can we do now? Well, we have a quadratic on top, so we'll try to factor it. So if we have x squared plus 5x plus 6, how could I factor this in a different way? Well, let's see. We could use the AC method. So what two numbers, when multiplied together, they'll go to 6, but they add to 5? Well, that's 2 and 3. So we'll say x plus 2, x plus 3 over x plus 2. Now we can actually just cancel these two out, leaving us with the limit as x tends to negative 2 of x plus 3. And now we can use direct substitution. So it'll be minus 2 plus 3, which is equal to minus 1. Sorry, to positive 1. Right? So that is the factorizing method. So there's one other method that's covered by the CAPE syllabus at least, and it is the conjugate method. Let's write that down here. Conjugate method. So let's say you have limit as x tends to, let's say 25. So what I'd recommend first of all is whenever you see these kind of things to evaluate if the limit is usable by direct substitution, normally just look for whichever one looks easier. So if you directly substituted this and put x as 25, you'd have 25 minus 25 as a numerator, because wherever we see x, would replace it with 25. And that gives us 0. We know that's indeterminable. So what can we do here? Well, we can use a conjugate method. So if you remember from, I think it was polynomials, was it polynomials? No, it was logs, indices, and surds. So if you remember from logs, indices, and surds, you can find the conjugate of something by multiplying. So let's find the conjugate of this actually. So I have x minus 25 over the square root of x minus 5. So the conjugate of this would just be the square root of x plus 5 over the square root of x plus 5. So now, multiplying these things through, we'll have the numerator, I'm sorry, so we'll have the numerator being, so we'll have x minus 25, and then we'll have root x plus 5. And under it now, so we'll have these two kind of terms, the root x sorry, I lost my train of thought. So we'd have root x minus 5, and multiplying it by root x plus 5. Now you could do this, you could, this times this and this times that, but that takes kind of long. So here's something you cannot use. You could use root x, whatever is in this position, minus 5. So we're in that position. And you can use this for anything. So it's a squared minus b squared. Right? Because this is the difference of two squares. So we can use that method. So in this case, we'll have, what's root x squared? That will be x, because if we have root x, it just cancels out. So that'll be x minus, what's minus 25? Sorry, what's minus 5 times 5? Well, it's minus 25, so we have to remember to add the minus sign there because, sorry, I did this slightly wrong. So, yeah, so if you have minus 5, so it's x minus and minus 5. Hmm. So you'd have, let's just do it the long way because I'm confusing myself right now. I'm sorry. Minus 5 root x plus 5. So we'll have x plus 5 root x minus 5 root x minus 25. As well, so we'll have x minus 25. Right. So we'll have x minus 25. My iCloud is like I'm out of iCloud storage and it won't ever let me forget. So my apologies. This b here, it doesn't matter what the sign is, you just put the value there. I'm sorry, I kind of messed myself up a little bit. But now we can cancel these things out and we'll have root x plus 5. So now we can take the limit of x, oh, as x tends to 25, of root x plus 5. So now we'll have root x is, the square root of 25 is what, 5 plus 5, and this will equal to 10. Right? Very, very simple stuff. You you can do this. And now let's get to a more, I wouldn't say difficult, but something that might actually be tested. Now, these other things, they'll be tested, yeah, but I've seen this tested a lot more than the other things. So, oh, oh my, such a stretchy line. Okay, there we go. So, let's say we have a graph here. Let me just change this to precision eraser. And we want to know if this is continuous. Before we get that, what does being continuous even mean? So, from the word, you know that it just means, oh, I'm sorry. It would mean that it continues, is straight, it's one line, it's just, there's no stopping, right? That's what continuous means. It just continues going like this. It's uninterrupted and it just keeps on going, right? And so we want to know if this is continuous. Now, if you look right here, there's just a gap in between, right? This is a random gap. Now, what is this gap? We'll call this gap a hole. That's what they're called. It's a literal hole in the graph. We don't know what that value is. It's indeterminable. So that's what we'll say. Nice. So this means that there's a type of discontinuity. So it's not continuous because there's a hole preventing it from being continuous. And this is called point discontinuity. No, there's another type of discontinuity. If it is that you had a graph and see you had it here and then it just went up to here. Like what? You were right here and you just randomly jumped up to here. This is called jump discontinuity. And there's one more, and it's infinite discontinuity. These things aren't like they're tested, but they're not tested in this form. It's just this form is kind of good to know. You can kind of see it. If you're ever asked to identify what kind of continuity it is, you can see it here. There's point discontinuity and jump discontinuity. So very good to know these are the different types of discontinuities, and this last one here is infinite. Now, let's actually get to something a little bit different. Let's say we want to test if something is continuous. So let me head up with continuity. So for something to be continuous, I would like to say I think there are like three. Yes, I'll say there are three not exactly, three rules that you need to know, right? So first we want to find out one, if there's a limit, sorry, if there's a limit of, as x approaches to a, of f of x, we'd want to know that, oh sorry, I didn't put the a there. So we want to know that f of a is defined. So that's the very first rule for continuity. We need to make sure it's defined. Now two, the limit as x approaches a of f of x should be equal to the limit of f of x as x approaches a. Now, what does this mean? Now, if you realize earlier, right? Earlier I said you could approach the graph from two different directions. You can approach it from the left and you can approach it from the right. Now, when you approach from the left, it's denoted by a negative sign because on the left of a graph, if you remember, a graph, the left side here is negative, right? I can't have negative there, but you get the point. And the right hand side is positive. So when you're coming from the right, you denote it as a plus. So what we're seeing here in the second law for continuity is that the left hand limit, oh my iCloud man, the left hand limit and the right hand limit must be equal. And lastly, what we need to remember is that f of a, which is what we tested should be defined from the start, it should be equal to the limit, as x approaches a, of f of x. Now, this time, we're not talking about direction because since these two should be the same, we can just call it a, since they should be the same, right? So what we want to make sure is that the first step that we checked if it was defined if f of a is equal to the limit of f of x as x tends to a, because it should be equal, right? So let's get into a past paper question. So a function f is defined as the following. So what we want to do is determine whether or not the limit of f of x as x tends to 1 exists. So does this function exist? Let's find out. So when x, you see there are three borders here. Let me use another color so I can show. Three things here. Now this might trick people. Well, I believe this is how you do it. So when x is less than 1, so right here, as you see right here, x is less than 1. Now, a lot of people would think, okay, if x is equal to 1 here, because we're going to use 1, right? We'll just plug in 1 and it will equal to 2. Well, that's not actually the case. What we're saying is that when x is less than 1, if you remember on a graph, what I kind of stressed on it earlier, we'll have 1 here. And when we're coming from the left-hand side, x is less than 1. You'll have 0 0.5, 0 0.6, etc., right? And when it's coming from the right, it will have 1.5, 1.7, things that are greater than 1. So when x is actually less than 1, what we're saying is that we're coming from the left-hand side. But regardless, we'll determine whether or not this limit exists. Now, how do we do that? Well, for a limit to exist, it must be defined. So, let's find. So, if it's defined, then f of 1 would be defined. So, f of 1, when x is equal to 1, is equal to 2. Okay, but when is the left-hand side now? When we have the left-hand limit being equal to the right-hand limit, or they should have the same, sorry. For this one to determine whether it exists, the left-hand limit and the right-hand limit should be equal. How do I say this? Well, they must be equal at x equals a. So I'll just put an at sign at x equals a. So when x equals 1, so we'll use substitution here. So when x is less than 1, this means that it is coming from the left-hand side. So we'll just substitute that in. So we'll have 2 times 1 plus 3, which is equal to 5. And when it's coming from the right-hand side, x would be greater than 1, right? Because as I showed here, if it's coming from the left-hand side, it has to pass 0 0.5, 0 0.6, 0 0.7, because it's these x values right here, they're less than 1. And when it's coming from the right-hand side, it's 1.5, 1. Everything is greater than 1. So now, since we want it to be greater than 1, we'll use the bottom one, this one right here, because it has to be greater than 1. So we'll say that 1 squared minus 1 over 1 minus 1, and this is equal to 0 over 0. So if this is the right hand side and this is the left hand side, the left hand side is not equal to the right hand side. This means that the limit does not exist. Okay? Do we understand that part? I hope you do. So let's continue. Now, what we want to do is determine whether f is continuous at x is equal to 1. So do you remember the 3 rules you have to have for continuity to take place? If you don't remember, they're right here. F of a must be defined. So we take f of a, and f of 1 is defined as equal to 2. Next, what we want to have is the limit of f of x should be equal to the limit of f of x. But this time, both sides should be equal. But from the working we just did to determine if this was even a limit, we can tell that the right-hand side, so the left-hand side, is equal to 5, and the right hand side is equal to 0. This means that the second rule, the second law, is not true. Therefore, at x equals 1, lim f of x, as x tends to a, is not continuous. I didn't know why I didn't just zoom out. But yeah, that's essentially it. I hope you understand a little bit more about limits right now. If this video was a little bit like, oh, my iCloud again. I'm sorry if this video was kind of stuttering. I was stuttering a bit, making a bit of mistakes. My apologies. I'm still getting used to this YouTube thing, and sometimes I'm just thinking a lot faster than I'm speaking, and it's a little bit hard to catch up sometimes. So I'm sorry about that. I'm getting used to it though, explaining these concepts, and sometimes I'm thinking about a different what I'm going to say next in my head, and it's just not kind of working out. But if this video did help you to understand even one thing, then I hope you enjoyed. I have more videos on pure mathematics, and they're available on my channel. They might not be the best yet, but in time they'll probably be better. And I'm currently a student as well, so I'm using this as both a way to help you and a way to help myself by revising. So most of the time I'm doing these videos without any textbooks. I'm just trying to do it from memory so that I can solidify the information. So if I'm making any mistakes, please feel free to comment them down below. I'm not perfect. As I said, I'm sitting the exam this year actually. So I'd just like to know anything I'm doing wrong. So yeah, I hope you guys enjoyed the video. If you did, you can watch more videos or subscribe if you are about that kind of thing. And yeah, thank you.